In part 3 of this lesson, we'll continue answering questions related to partial derivatives. Recall that in order to represent a partial derivative with respect to, let's say, x or y, you denote it as f sub x, or the partial derivative of f represented by this stylized letter d with respect to x. Now, with that being said, in question number 1, they ask, given the equation shown on your screen, find the partial derivative of our equation z with respect to x. Now, what's interesting about this particular question compared to the ones that we found in part 1 and part 2 is that to find f sub x, we keep y as a constant, but z depends on x. So we'll have to find the partial derivative implicitly. Now, if that's confusing to you, take for example the first term. I'll write down f sub x is equal to, and according to the first term, we don't have an x value, but we do have a z, and remember, y is a constant. So we'll take the derivative of z implicitly, and that will give us 5 times 2, we're using the power rule for z, times z, and y is a constant. Now, because we're doing it implicitly, we'll have to write down the partial derivative of z with respect to x. So that's the derivative of the first term. Now, for the next term, this part, we have to use the product rule. And if you recall, the product rule goes something like this. If we have a function, u times v, we take the derivative of u, and we multiply it to the factor v, and then we take the derivative of v and multiply it to u. So in our case, here we have, let's call this u, and we'll call this v. We'll start by taking the derivative of u, and that is, with respect to x, and y is a constant, we have y to the power of 3, times v, so sine z. And now we'll take the derivative of v. The derivative of sine z is equal to cosine z. And taking the derivative of z is the partial derivative of z with respect to x times u, which is x y to the power of 3. X y to the power of 3. If we clean this up, we should have, the next step is to isolate for the partial derivative of z with respect to x. And the way we do that is by bringing this term, which doesn't have this as a factor, over to the other side, therefore giving us negative y to the power of 3 sine z is equal to the two terms that were left behind. Now, we can factor out this on the right side, leaving us with 10zy plus cosine z xy cubed. And all of this is in brackets. The left side stays the way it is. And we divide both sides now by this expression, giving us what we're looking for. So just to be clear, we'll divide both sides by what you see up here. And you end up with what they're asking for. That's the answer to question number 1. Let's move on to question number 2. We're asked, can we extend the concept of partial derivatives to apply to functions of 3 or more variables? And the answer is you can. In our question, they want us to find out f sub u, f sub v, and f sub w. So starting with f sub u, we'll take this as a constant, that as a constant, these two as constants, and this v as a constant. The variable that we're differentiating with respect to is right here. And that reminds me of when we took the derivative of 2 to the power of x. That was equal to 2 to the power of x ln 2. So we have to do the same thing here. We have to use this pattern. In our case here, for this factor, we would write down wu times ln w. And since these are all constants, they are written as factors. And now we focus on this term. V is a constant, u isn't. Taking the derivative of u is 1, using the power rule, leaving us with 5v. Now let's find f sub v. To find the partial derivative with respect to v, we have to use the product rule, because we have v here and v here. We'll take the derivative of these two factors. We end up with 3v squared wu, and we'll leave that part the way it is. And now we will leave this the way it is, wu v to the power of 3 and take the derivative of that, which is e to the power of 9w minus 3v squared. That's a constant, it goes to 0, and this becomes negative 6v to the power of 1. Plus this part, and taking u as a constant, taking the derivative of v, we end up with 5u. And lastly, f sub w, we'll take everything that's not w as a constant. So starting here, we once again have to use the product rule. So we'll consider this as one factor and this as the other. Taking the derivative of this, we end up with v to the power of 3, w, u minus 1, and it's being multiplied to u because we bring the u down. We're using the power rule. That part stays the way it is. E9w minus 3v squared. Now we will leave that the way it is, w u v to the power of 3, and take the derivative of that. The derivative of 9w is simply 9. This goes to 0, and all of that goes to 0. So that's the partial derivative of the function with respect to w. And there you have it. Two more examples on how to find the partial derivative of a function.